Hey there, my name is John Grimsmo, and in this video we're going to talk about this little guy. This is a pivot made by alphanifesupply.com, and when making a knife, a pivot is basically the epicenter of the whole knife. That's what the blade swings on. So like on my knife, pivot right here, blade rotates on pivot, pivot very important. Using a high quality pivot that's very consistent is very important to making a very consistent knife. Now people have used like anything from a screw to a barrel to all kinds of different things, and there's lots of different ways to do it, but I like to use Alpha Knife Supply pivots. Mainly because the tolerances are just perfect every single time. On their site they list within 2/10 of an inch, which is sort of aerospace standard, but they actually are, because I used my micrometer and measured. The downside to them is that they're very long and they have a very big ugly head. But I'll get to that in a second. The upside are that the threads on the little screw here are 6/64, which is it's a non-standard but very fine pitch thread. Very fine pitch thread, which means when you're using your little torque screwdriver to tighten the pivot to the exact right amount, the fine thread pitch gives you more leeway. Like a quarter turn is a good adjustment range as opposed to just like a tap. So the fine thread pitch is very cool, and I really like working with that. It just really lets you fine tune the pivot to exactly what you want, and I'm picky like that. They're made from 416 stainless steel, heat treated to 42 Rockwell in a vacuum furnace, so they are very good stuff. Now, as I was going to say, the downside is that they're a standard size. They're way too long for me and the head is ugly. So if you put it in your knife handle like that, you got a head that sticks up and looks goofy and isn't very cool. So how do you customize such a pivot to be awesome? I've heard of guys doing all kinds of crazy things, like engraving it by hand into a rose or something like that, or just flattening them off, or using a lathe. That's the most common way, I think, is to use a lathe to face it off so it's flat, or dome it or something like that. Since I love using my Tormac for pretty much everything that I can, I have figured out a way to use that to shorten these in bulk, quickly, easily, and make them awesome. Now, how I shorten them, we'll get to in a second, but I wanted to go over a couple things first. For this last batch of knives, I started engraving the pivot with my Viking head logo, which turned out, just wicked. Except what I didn't realize is that over time, I Loctite all the pivots, but sometimes it doesn't stay. Okay, this one is Loctited. But to prove a point, I just kind of unscrewed it a little bit, and the freaking pivot rotates. Yeah. So anytime you have a reference point on the pivot, like an engraving, a symmetrical engraving, you got to realize it's going to rotate, or it has the potential to rotate. So after a few weeks of use and flipping it and stuff, I've noticed a lot of the knives in this batch kind of just kick a little bit counterclockwise, not this much, but just a little bit to look dumb. And then you got to mess with it again, and the pivots are cool because the shaft is 0.1870, and the little head up here, I don't even know if you can see it. Yeah, you can see a little bit of a line just above my thumb there. The head is 1875, or not the head, but the top of this shaft here. 1875, and then the shaft is 1870. So the shaft is 5/10 smaller, which means if you ream your hole to the right size, then that little lip will press in there and hold it tight, but sometimes not tight enough. Lots of guys have figured out ways to keep this pivot from rotating, but the way that I figured out for this new batch of knives that I'm working on now is to go something like this. Ovalize it. Not exactly an oval, but it's got these two flats on the side. There we go. And with those two flats, put it in, slips in perfectly. It's got the tiniest bit of wobble, which is perfect. That's what you want. And yeah, boom, we're back in business. So now it only goes in one of two ways, either the obviously wrong way or the right way. So anybody disassembling the knife and, you know, playing with it pretty much can't mess it up. So I like that. That's cool. So yeah, this oval pivot is a new thing for me, and I'm really excited to do it that way so that we don't get stupidness like this. Sorry guys, everybody who's got a third batch knife that says, I think it says March 2013 inside. Well, anybody with the engraved pivot up till now, it's got the potential to rotate, and I'm sorry about that. But what are you gonna do? You live and learn. So it's right now it is Loctited, and it's got a good tension on it, but I'm able to mess with it. But this will solve that. So as I said before, they are way too long. Stock size, my size. What most people would do is they would chuck it up in their lathe in the chuck like this, and then use a turning tool to turn it down. I've done that before, and it works okay. If you had like a collet, it would fit a lot better, but this isn't a lot of material to grab onto. It's got the potential to go crooked, to fall out, and it's not the most accurate and repeatable way to do it. And when I'm putting together a big batch of knives, the repeatability is key. If I can make these to the exact size every single time, then I don't have to mess with them later, which is perfect. So I figured out my perfect size here, and now every one is plus or minus 1 or 2 thou thick or length of all of them, which is perfect. So what I've done is come up with these soft jaws to go in my vise right here. And you can see all the pocket, oval pocket at the bottom, and the reamed hole going down like that. And I sort of calculated all the tolerances and distances and everything in my CAD software so that I could put this in, and it loops at the bottom there. And since these are made so so perfect length, the thickness of that head and the dome and everything is the same on every single one. So I can just put it in there, and it just stays with gravity like that. And then I'll put another one over here just to make it even. Then I tighten it down, and this other jaw has the same slots on the other side. And then it just clamps them down like that. And they don't have to be very tight, just nice and snug. And then there you go. So now it's tight, it's repeatable. When I zero the machine, I probe off the surface and off the side of the jaw and off the side of the jaw. And sometimes I'll even take my probe and I'll go inside the hole and I'll center the hole itself so that I know exactly that this is where it's supposed to be, instead of relying on old dimensions and all that. Anyway, oversharing. What most people would do in this situation is to take an end mill. This is a 1/4 inch 4-flute end mill from Lakeshore. They would just take it and just cut it straight across. It works, but it's a little hard on the end mill because it's, you know, it's a hard entry and then it's 2 walls and then a hard exit, and it's not the most efficient way to do it. It's probably the fastest way to do it, but as far as tool life and accuracy of the part and all that, I don't know. So what I did is I coded by hand a spiral toolpath that's sort of like high-speed machining, how it goes full depth of cut and uses as much side of the end mill as possible to just spiral around it and take off a very thin wall thickness all the way around. And I just think it's cool. I think high-speed machining is cool, and spiral toolpaths like that are very cool, and they leave an awesome surface finish. So let me show you one. See how easy that was? Beautiful chips flying off. And then for the ultimate luxury, I come in with a little chamfer tool. And I put a teeny tiny chamfer on both sides. So now that is completely finished. They're all, like I said, within 1 or 2 thousandths of length, which is perfect for me. They got a nice chamfer on them. They're not sharp. They're perfect. They go in easy every time. It's just wonderful. I love it when a plan comes together. And then, luckily, when you take them out, they hook underneath and they kind of stay there. Now part 2, now that it's short, is to get rid of the ugly big top head thingy and make it nice. So, same fixture, same zero, same everything. I just drop it into these holes. Put another one over here just to keep the tension even on it. Snug. Turn the vacuum on. Let's go. Notice how I had a really slow finish pass there. Beautiful. And there we go. That's not bad. One thing I had to be careful of last time, I think you can see it on my knife. If you look really close, right between the dude's eyes, just off center between his eyes, there's a little dot, and that's actually a hole that goes through to the drilled hole on the other side. So when they drill it, when they make it, and they drill the center hole all the way through it, you know, that hole goes so far. And I was actually shortening the head so short that it would just poke through. And not during the facing, but just during the engraving. So pretty much every single one has the exact same, you know, little bit of an eyeball in the engraving. Which is cool because it shows that their drilling consistency is very, very accurate when they make these things. It's very impressive. But this time I have to make them a little bit thicker so that they don't do that. I don't think anybody is ever going to notice until now when I just told everybody. But that's that. So anyway, that is how I modify a 3/16 alpha knife supply pivot and make them uber awesome. Very high quality pivot. I'm happy to use them. They're not too expensive, and the quality is worth every penny. I guess the last part of the equation is the screw that it comes with. It's black oxide coated. I believe it's black oxide, I'm sure it is. Which works fine for most knives. It's kind of a dull black color. But for blingy cool knives, it's nice to have it kind of shiny and silver. So what we do is we just chuck it up in our cordless drill. Just hold it by the threads. Just right there by the threads very loosely. Spin it against the Scotch-Brite wheel or against some sandpaper, and then just get finer and finer grits, and then against a polishing cloth with some rouge. Spin it, spin it, spin it until it polishes up. So they're pretty easy to shine up. I kind of wish they had an option for these not black, but they wouldn't be shiny polished, they would just be silver, so you'd still have to polish them anyway, so it's kind of moot. Kind of a mute point. Anywho, and I dropped it. That's my video. Thanks guys, bye.